Good evening, dear students. Welcome back to Electrochemistry Part 2. In this part, we discuss about the ways of expressing concentration. Different ways of expressing concentration of solution. As you know, the definition of solutions, different types of solutions. Third part, according to our syllabus, that is ways of expressing concentration. Different ways used for expressing the concentration of solutions. Here, first one is mass percentage of the component. Here, we are discussing about binary solutions. Therefore, two components present in binary solution. W1 be the mass of solvent, W2 be the mass of solute. Therefore, mass percentage of solute is equal to W2 is equal to W1 divided by W1 plus W2 into 100. Here, W1 mass of solvent, W2 mass of solute, W1 plus W2 total mass of solution. For example, 5% solution of sugar means 5 gram sugar dissolved in 100 gram of solution. Next is volume percentage. Volume percentage, if V1 and V2 are the volume of solvent and solute respectively, V2 be the volume of the solute. V2 is equal to volume percentage of solute, V2 is equal to V2 divided by V1 plus V2. V1 plus V2 means total volume of the solution into 100. That is the volume percentage of solute. Third, mass by volume percentage. Mass by volume percentage is denoted by W bar V. And here, mass by volume percentage, W2 divided by V1 plus V2 into 100. Here, W2 mass of solute, V1 plus V2 be the total volume of the solution. Clear? Fourth one is mole fraction. As you know, mole, the term mole. Mole is the amount of substance, chemical substance. Amount of chemical substance is denoted by the term mole. Here, from the word it is very clear, mole fraction means fraction of mole. If N1 be the moles of solvent, N2 be the moles of solute. Therefore, mole fraction of solute X2 is equal to, X means X is the term denoted or used for mole fraction. X2 is equal to N2 divided by N1 plus N2. N2 be the moles of solute. N1 be the moles of solvent. N2 by N1 plus N2. Number of moles of solute divided by total moles of all the components present in the solution. And you already know X1 plus X2, that is equal to 1. X1 mole fraction of solvent, X2 mole fraction of solute. Total mole fraction of all the components in the solution is equal to 1. For example, if a solution contains n number of components, therefore X1 plus X2 plus X3 plus X4 etc. Xi is equal to 1. Here, mole fraction means fraction of mole. So, if you are adding all the fractions, finally the total value will be 1. Then, next is, fifth method is molarity. It's very important. It is denoted by the letter capital M. Here, molarity is the number of moles of solute dissolved in 1 liter of solution. Here, we are taking solution in liter, volume of solution in liter, N2 number of moles of solute, V volume of solution in liter. Therefore, molarity M is equal to N2 divided by V in liter. Molarity, number of moles of solute dissolved in 1 liter of solution. Then, the unit of molarity, that is N2 number of moles. Therefore, mole, and then V volume, moles per liter. Moles per liter is the unit used for molarity. And then molality. Molality is denoted by the term small letter m. And here number of moles of solute dissolved in 1 kilogram of solvent. Here we are considering weight of solvent in kilogram, but in the case of molarity, we are considering volume of solution in liter. Volume of solution in liter in the case of molarity, but in the case of molality, we are considering weight of solvent in kilogram. W1 denotes the weight of solvent, that is represented in kilogram. N2 be the number of moles of solute. And here the unit of molality is moles per kilogram. Mole kilogram raised to -1. So molarity of solution 0.05 molarity of NaOH means 0.05 moles of NaOH dissolved in 1 liter of solution. 0.05 moles of NaOH sodium hydroxide dissolved in 1 liter of solution. Molarity 0.05 means 0.05 moles dissolved in 1 kilogram of solvent. So molarity in terms of kilogram, molarity in terms of volume. Okay. Here mass percentage W2 is equal to W1 by W1 plus W2. Volume percentage of solute is equal to V2 by V1 plus V2 into 100. Mass by volume percentage W by V is equal to W2 by V1 plus V2 into 100. Mole fraction X2 is equal to N2 by N1 plus N2. Total mole fraction of all the components in the solution, that is equal to 1. Then molarity, number of moles of solute dissolved in 1 liter of solution. Molality, number of moles of solute dissolved in 1 kilogram of solvent. These are the different ways used for expressing the concentration of solutions.